So yesterday we discussed list, set, and map and its methods and its subclasses and also methods, right? So most of the time, the frequently used collections I have explained here. Okay, so similarly, like hash map, we have also linked hash map. Okay, whenever you add the elements to the linked hash map, those will be stored in a order, whatever the order we set. In the same order, those will be stored. So today we will discuss the stream API in Java. Okay, we have one stream API, stream. Okay, if you want to write some lambda expressions in collections, we have stream API to process the collection data. If you want to process the collection data, list, set, and map, or any other collection data, we have stream package. Okay, how to use it I will explain. But if you want to use the stream API, okay, you must know the existing functional interfaces. So earlier we created functional interfaces and we used functional. Okay, we write the functional interfaces for lambda expressions for functional interfaces, right? So we have some default functional interfaces which help us to use in the stream API. Okay, so let me create in the functional interfaces section only. I will create one class. Built-in functional interfaces. Built-in functional interface. So whenever we say functional interface, okay, if you want to use that functional interface, either you have to use anonymous class or you have to use the lambda expression, right? The first functional interface is function only. Function. Okay, it can accept any type of value and it can return any type of value. So let me accept as integer. I want to return the value string. Okay, it is a functional interface. It is a functional interface. Okay, you need to implement the unimplement methods in unimplemented methods in the anonymous class. This is the anonymous class. This notation we already see. Add unimplemented method. So there is one method apply. Okay, it is returning. It is accepting integer. You can return any value. It can accept any value and it can return any value. That is the use of function. Okay, the same thing if you want to write, how you can write. So this is the functional interface. Okay, this is the object and already a method you assign. Instead of writing this entire thing, what we can do, we can write the lambda expression, right? So first let me call this method, apply method. So if I pass 100, so in Selenium also we use this functional interface. That is the reason I'm explaining. See, you are passing 100, but it is printing some text. Okay. So this functional interface, if you want to convert into lambda expression, what you can do? Simply okay. So you have one parameter, okay, some val. It is accepting two. It is accepting any type of number and it can return any type of value. Okay, but it is accepting only one value. Team is only one value. Okay, or you can say val. So let me use it is accepting value. So here, if you want to return, the same thing you can write with the help of lambda expression. Okay. So if you call function to apply method, you are getting the same result. Okay. So we have some functional interfaces. So these functional interfaces also we can use in our programming. So how we are using set list and other interfaces similar way. So we have one more interface, predicate. Predicate. Okay. So it accepts one value, any type of value, any value. Predicate 1 equals to new predicate. Okay, inside this there is one method. Implement that method. So here we have test method. We have test method. It always returns true or false. It always returns either true or false. Okay, so here I will put the condition if. So this is also, let me make it as val. Val means value. Val greater than 100. Okay, return true. Return true. Else return false. Okay, it always returns true or false. Suppose if you want to check some collection, in the collection some values, if you want to verify, okay, you can pass any value, you can put any condition, but it always returns true or false. So if you want to call this method, how you can call? Dot, this is the test method. If you pass 90, see, are you able to follow this notation what I'm writing here? This we already discussed it, it's anonymous class. And also with functional interfaces, writing lambda expression also we have discussed in our previous classes. See, false. 90 is not greater than 100. False. So the same thing if you want to write as a lambda expression. So test method. Okay, this is the method, test method. It is accepting one value. It can return true or false. The same condition you can put here. You want to write in multiple lines or a single line, that's your wish. Okay, the entire thing you can write in a single line or multiple lines. So here the same method I call with the lambda expression. Okay, if you pass 90, so it is false. So no need to write this entire thing. So let me write this in a very simple format. So val, you can simply remove this everything. Predicate 3. Return statement also not required here. But let me see. Value greater than 10 if val greater than 10. So here it is mandatorily asking that second statement also. Okay, but when we are using in the stream API, that time it won't ask. Okay, that we will see later. Okay, so let me remove it as of now. Okay, like predicate and function. Okay, we have one more built-in functional interface, consumer. It also can accept any value. But it won't return any value. It won't return any value. It is not returning any value. The method is a void type. Void type. So here function returns any type of value. Predicate returns only true or false. This consumer, it can return, it won't return any value. You can simply print the value. Print the value means suppose I want to print whatever number I am passing, that I want to print. Okay, so number. So let me make it as val. Just put it as val. So you can call this accept method directly. If you pass 100, it prints that 100. It won't return any value. So the same thing if you want to write as a lambda expression. Somebody want to try? Anubhav, tell me how to write lambda expression this consumer. Your voice is not audible. Hello? You are not audible, Kondababu, if you are trying to speak. Okay. So anyone, Kalyan, Sai, and Ravi, you want to try?
No.
Yeah, Kondababu, speak louder.
No.
Yes, yes.
Take a variable value val.
Just tell me the code, or you can type in the chat box and ping. See, we want to write the lambda expression for this anonymous class. How you will write? So we are discussing this one only, right? So it's very simple. Inside that you have one method, accept method. No need to use the name, first of all. Put the parentheses. Suppose if it is accepting some parameters, okay, put that parameter here. If it is accepting more than one, val2 also you can write. Val3 also you can write. If it is not accepting any parameter, just put a parenthesis. So here it is accepting one parameter. Just put that as val. Just put hyphen and greater than symbol. Put the curly brace. So here it won't return anything, right? Just print the statement. Simple. This much simple. But while you are calling, you can call the accept method. Here you are not mentioning any name, but here you are calling the accept method. Okay. So you all are not practicing. I think just listening and forgetting the concept. Okay. So you can minimize your code with the help of functional interface. Okay. We have one more functional interface, that is comparator. Comparator. Okay. It is also accepts one value. New comparator. So here it is having one compare method. Compare method. See, this comparator, what is this comparator? What is the use? So whenever you have some elements in your list object or set object or map object, in which format values are storing into the collection? That list or set or map collection. Those are storing into in a object format, right? So yesterday we have seen, and also we did sort also. We did sort also, we have performed sorting the collection. With the linked list we did, and also with the default method of sort. But if you want to sort the elements in the set, if you want to sort the elements in the set, you don't have the sort method here. You cannot sort. Sort won't work. Okay? Because sort method is only for list. And again, so let me show you one example so that you will get clarity. So let me create one class. Okay, inside functional interfaces only, I will create one class. Class name is student. Student. Finish. So student, they has name. Okay, so write int roll number, int name, sorry, string name, and string class name. Okay, so let me generate setters and getters for this. Okay, Alt Shift J, not J. What is the shortcut I have provided for setters and getters? So let me take the help from Google. Alt Shift S. Sorry. Alt Shift S. So generate setters and getters. Okay, for all your three fields. Okay, public methods only. So generate. It is generated. Okay, what I do is I create a constructor student. Through the constructor, I will assign the values. Okay, so like this. So we have one Pojo class. So generally writing the setters and getters and writing the fields, we call it as Pojo class. Okay, this entire class we call it as a Pojo class. So here we have one student class. Okay, so we can create multiple students, right? So let me go to our built-in functional interfaces. Okay, so before explaining this comparator, what I do is student. Okay, let me take one list which should accept student type of data. Okay, so if you pass integer, it takes students list, new array list, new array list. So import these two. Okay, if you want to import, so there are two classes, right? So every time what you have to do, put your cursor here. So it is going, okay. You have to put the cursor here and you need to import. And you have to put the cursor here. Okay. New array list. open. Okay. So you need to import this. So we have one shortcut key, Control Shift O, which can import all your unimported packages at a time. Okay, so let me remove these two, array list and also list. This I'm removing here. Okay, so now you are getting two errors because this one and this one you need to import. So if you want to import all these two packages, array list package and list package at a time, okay, Control plus Shift plus O, shortcut key, Control Shift O. It will import those packages directly. Okay. Yeah. So I have student list. Okay. Let me add student details one by one. Student details. Dot add new student. Okay. Here we need to pass roll number. Some three. Name. Some raw. Class. Some 10th class. So similarly, let me add one more student to the list. New student. This is 1. From Kalyan. 10th. Okay, let me add one more student. This is 2. From side. Again 10th. Okay. Remove arguments which match with student. What happened? The method add int student in the type not applicable. The method add int and student. So we are not using that method, right? We add student object. Oh, okay. So the problem is, so we have to add students like this. Add the student one by one. Okay. So if I print this student list, okay, it prints in a same order. Okay, so and also it is not printing any list. Okay, because each one is a object. Each one is a object. So if you want, you can print one by one value of each object. Okay, so here these are stored in this order. So you want to sort these students objects. These student objects, if you want to sort, how you will sort? Okay, so let me use the sort method. Let me use sort method of list. Okay, collections dot sort. Okay, let me put this students list. See, you are getting error. But earlier in the list collection, okay, in the list collection, So when you sort, it is not giving any error. Primitive type of data, it is not giving any error. But when you try to sort these objects, it is giving the error. In that case, what we have to do? So basically, we have two approaches. One is we have one comparable interface. We have one comparable interface. That comparable interface we have to use in our student class. Suppose if you want to sort in the future, what you have to do is simply implements comparable interface. When we say comparable interface, or you can put student only. Okay. When you implement some interface, what we have to do? Unimplemented methods you have to implement, right? Okay, here add unimplemented method. So we have one more method, compare to method, which is also accept student object. This let me make it as student obj2. So here just we need to write one if condition. So if you want to take the current class object, this student class object, okay, so we have this keyword, right? This dot, I want to sort with roll number. So I'm calling the roll number method. Roll number is greater than. So through this method also we are passing the student object only, right? Roll number. Then return 1. Else if or you can simply put it as else less than, if it is less than. Okay, you can return -1. Okay, so instead of writing this, we can simply ignore this. Okay. So before like calling this comparable method, before calling the sort, let me print. So now see the error is gone. When I implement the comparable interface, this error is gone. Okay, when I call the comparable interface. So let me show it again. So let me remove this. Okay, and also let me comment this, or you can override, you can comment. See, this sort is giving the error because it cannot sort the objects. It cannot sort the objects directly. It cannot compare basically. So in student class, so when I implement the comparable interface, how this sort is not giving the error. Okay, so before sorting, how it is printing the values. After sorting, how it is printing the values. Let's see. Okay, so this is a list you can use for each loop. Students list dot for each I'm using here for each. So what it is giving? It is accepting consumer. We discussed it here, consumer. Okay, consumer can accept any value and it won't return any value. So let me use consumer only here, consumer. From the consumer, I just need to print. I cannot do anything. I just need to print values, right? Okay, so this consumer, it is accepting value. Okay, one value, student object, student obj. That value it is accepting. Okay, here you can print the you can print the student object. If you want to get roll number, you can get from the student object. Okay, from student objects, I want to print roll number dot roll number, get roll number 1. I want to print the name also. Same line I'm writing that. Okay, roll number space name. If you want to get the name, we have created name, get a name method also using Pojo classes. I mean, using setters and getters, we written the get name method also. So here, student object dot get name. Student object dot get name. So here you are getting the roll number, and here you are printing the name. So let's see what's happening. Let's run it. 3 Ram, 1 Kalyan, 2 Sai. Okay, whatever the order we stored, those order only it is printing, right? So now here, after sorting, let me print the same thing. Before sorting and after sorting. Before sorting. And after sorting also, I will print. See, here we are sorting. After implementing the comparable interface, we are sorting it. So let me print it. See, before sorting, the values are printing like this. After sorting, values are printing like this. So in a sorted order, these are printing. Okay. So, but the dependency is when you are using comparable interface, the dependency is, so again, you have to override the compare to method in our existing class. But suppose if somebody provided this student class as a dot class format, in that case, you cannot edit this code, right? You cannot edit this Pojo class. In that case, what I have to do? Okay, I want to do the sorting, but somebody has provided the student class as a dot class file. You can use it, but you cannot edit. Okay, these setters and getters, these field values you can access, but you cannot edit. In that case, we can use the comparator interface. What we have to do? Comparator interface. Here also, you can do the same thing. So here, so this sort, let me comment. Okay, with the comparable interface, let me comment. Okay, so here, let me remove this. Excuse me. Or let me do one thing. Okay, instead of okay, let me create one more class, the same class with a different name. Students. In the students, I remove this one and also I remove this override method. I have setters and getters fields. This is a Pojo class. Somebody has implemented, some other developer, he gave me as a dot class file. I cannot edit, I cannot override compare to method using comparable interface. Then I want to sort this students class, students object. Okay, so here, let me create one more list. Okay, so this one I will make it as it is. Let me create one more list, students list only. So student here, let me make it as student list, that is students list. This is students list. Okay, this is different and that is different. Again, okay, so before sorting, this is after sorting students. After sorting with comparable. See, this is very, very important interview question. That's why I'm explaining. Comparable interface. So if you attend Java interview or Selenium interview, whatever the interview you attend with the Java backend, you will get this question. That's why it is important. Comparable interface. So now, so this is before sorting. Let me print, or let me take some other names too, or let me add roll numbers like this. Okay, let me put some other names. Some 11th grade. Okay, just to show the difference. Okay, before sorting. So before sorting, what we have to do? We have to print. See, before sorting, whatever the order we stored, the same order, the values are printed. Okay, so if I want to sort students class, okay, so here not student, it should be students. Okay. So here, this constructor also should be students only. No, that is fine. Why we are getting error? This is students. Yeah. Okay. So I want to sort, but this students class, it cannot be edited. You cannot implement comparable interface and you cannot override the compare to method. In that case, what we can do is we can use the comparator interface. We can use the comparator interface using which we can sort. Okay, in comparator interface, so let's pass students. So here you have to put the same condition in the student how you did. So here you should not use this. You have to use obj1, obj2. Okay, so obj1 dot roll number is greater than obj2. So now I want to compare, I want to sort this one. So we have one more method. Let's see. If you want to sort students dot sort. Okay, here what it is accepting? It is accepting comparator. This is accepting comparator. See, what are the comparator I created? That I have to pass. Okay, but earlier, whenever you are using, okay, so we have collection dot sort also, right? So let me use that. So you see, you have collection dot sort. Again, what it is asking? Comparator. You can use in both ways. Okay, one is your students list and your comparator you have to pass. This is one way sorting, and directly you can sort like this: student sort list dot sort dot comparator. First, let me sort with collection dot sort. Then let me print after sorting after sorting with comparator, functional interface. Comparator functional interface. Okay, so this is students list, each object, this is fine. Okay, so let's print again. Let's run again. See, values are sorted in a sorted order by roll number. Okay, let me comment this. So now run again. See, you are getting the same. Okay, so you can use it for any collection. This notation you can use it for any collection. So here, what I do is, instead of writing this entire code, we can simply use, so comparator 2 equals to, so we have one method inside that. What is method? Compare, which is accepting two elements, right? obj1 and obj2. Okay, this is the method you have. Inside that, you have to write the logic. Which logic? This logic. Okay. So you can use compare 2 method also, comparator 2 also. Okay, let me comment this. If I do with compare 2, you are getting the same. This is the lambda expression. Okay, the same thing, you can use it in this format also. Okay, getting or not? So we discussed function. In Selenium, we use function. Let me show you one example in Selenium where we use fluent weight in Selenium. Okay, so fluent weight in Selenium. The syntax I want to show here. See, this is the syntax for fluent weight. So in fluent weight, here they are using function, new function. It is not new one, okay? It is function. See, 90% people don't know about these functions, but they directly copy and paste and they will use there in programming. Here, instead of writing this full syntax, we can write lambda expression. Okay. Are you able to see my screen? Hello?
Yes, sir.
Yes, yes.
Okay, so see.
Yes.
So whenever we write any code in Java, you should not copy and paste, or you should not blindly type some others programming. First, you have to understand the background logic. Then you have to implement by your own. In that way, you have to learn. See, 90% people don't know about this function. Okay, who works for a long time in Selenium, who experts in Selenium. Okay, so yeah, we discussed functional interface, function, predicate. We have discussed predicate. We have discussed. So let me write like this. This is function. Okay, so this is predicate. This is consumer. We have so many functional interfaces, but useful only I'm explaining here. Consumer. We have one more thing, supplier. That also let me explain. So here, consumer, after consumer, yeah, so we were discussing what we are discussing, comparator and comparable. So comparator only functional interface, not comparable. Okay. And also we have one more interface, functional interface, not normal interface, functional interface. Supplier. Supplier. It also can accept one value. Supplier. One. New supplier. New supplier. So you have one method inside that. Inside the supplier, you have one method that you need to override. That you need to override. It won't accept any value, but it can return some value. Okay. It won't accept any value. First of all, you cannot pass any value, but it can return integer. It always returning the integer because you are passing the integer here. So let me remove this. Let me put it as string. So whatever the type you are passing, the same type you can get. So let me print hello. Hello supplier. Okay, so let me make it a string at least because I'm returning the string. So you can call supplier. Supplier dot. What is the method we have? Get method. Okay, it is returning the string. Let's print it. This is supplier. This is also somewhere we will use. Okay, the same thing, let me write in a lambda expression format. Now can somebody tell me how we can write this lambda expression? Anyone want to try? Tell me. Pandababu, Ravi, Kalyan, anyone? Mojesh. Yeah, Mojesh. Yeah, so just tell me the syntax, what I have to write here first. It is, we have to call the get method. We have to write the lambda expression for get method. So here, how I need to start? Anyone can answer. See, we return like around 4 to 5 functional interfaces, the same format. So this is without parameters, lambda expression without parameters. Kondababu, would you like to try? Speak loudly. Okay.
Okay.
You want to try or not?
I'm trying, Shiva.
Try means what?
In the chat box.
Okay, you are typing in the chat box. Okay, okay. Try it. It is not accepting any value, but it can return the data. That is the reason I'm printing here. Okay, if you want to convert this into lambda expression, how you will convert? It's very simple. Till you are typing. Still not done. It's very simple syntax. Now, are you typing or shall I go ahead and explain?
20 seconds. It's finished.
Finished, huh? Okay, ping it. So this won't take much time basically. Okay, but why you are taking this much time, I'm not sure.
It's finished.
Finish it up.
Yes.
Did you ping me? Wait.
Ping.
Okay. See, again, this is the mistake. This is the mistake. Is it accepting any values, this method? So here you have a supplier. Is it accepting any value? Get method is accepting any value. Is it accepting any value? It is not accepting any value, which means no need to pass any parameters. See, whenever you are writing a lambda expression, just concentrate on the method. It is a method. It is not accepting any value. Do not pass any values. Do not pass any value. It can return any value. Return hello Java. And with semicolon. So when you run it, when you call with the supplier 2 also, you will get the same output. It's this much simple. I don't know why you are confusing here. Okay, so before where is supplier? This is supplier. Hello Java, hello supplier. Okay, here I'm passing hello Java, right? Hello supplier. In both the cases, it is printing hello supplier and hello supplier. Okay, why it is printing number 100? After supplier, it is printing number 100. Okay, in consumer, it has to print consumer accept 100. It has to print 100. It is fine, but again, it is printing. Okay, consumer 2 we are using here, so that is the reason. Okay, yeah. Yeah. supplier. Okay, then what is the use of these functional interfaces? Where we use? We have one special package to process the collection type of data. The package name is stream. Okay, in functional interfaces or collections, I will explain that. In collections, let me create new class stream API. Stream API example. Stream API. But suppose I have a list of numbers, list of integers. List one, numbers list. New array list. So you have added some numbers. Add 1. And let me put it as 11. There are some numbers. There are some numbers. So your requirement is to print the even numbers or odd numbers. Even numbers or odd numbers. Generally, how you will do? You will use the enhanced for loop. Again, from this numbers list, you will accept one by one value. Object, each value. Again, you will put the condition if each value you will convert. Each value you will convert as integer. Percentile 2 equals to 0. Okay, you will make it as you will just print, or if you want some other list, only even numbers list. Even numbers list. What you will do? Dot add that value, add that each value. Okay, so here integer type of list we have taken, right? So while you are storing the value also, you have to you must, and the values are integer, right? No need to specify. Okay, so here you can use integer or you can use int also. Here also no need to specify. Okay, like this you will do the why 0 is getting error. Let me put it as int. Okay, something is missing here. Okay, so now you will print even numbers list. So this is the logic generally we can write, right? If you run it, it prints the even numbers list. Similarly, for odd numbers list, what you will do? So you will change the condition. If you get a remainder 1, it will become a odd numbers list. Generally, we will do. So instead of writing this for loop and everything, what we can do is simply we can write. So this is the number list. Dot. We have stream API, stream package. Stream. Dot. To filter the even numbers based on the condition, we have filter method. So filter method, what it is accepting? It is accepting predicate. See, predicate. Okay, if you go to our functional interfaces, built-in functional interfaces, predicate method. Where is predicate? So this is the predicate, right? This is the predicate. Okay, inside that predicate, you have, it is accepting value, one value. It can check the value is positive. I mean, value is even or not. So here you're putting the greater than 100, but you will check val percentile 2 equals to equal to 0. You will check. Okay, to check the even or not. So if you want to write the lambda expression like this, how you can write in the Stream API. So here it is accepting one value. Okay, each val. Here you can put the condition. Which condition? If each val percentile 2 equals to 0. Then you can return true. Okay, so this is for this also put the curly brace. So here you can put the curly brace. Yeah. Here also end it here. So filter each value. Okay, for this we have opened. This is ending here. This is fine, and also this is ending here. This is also fine. Why we are getting error here? Syntax error. Something is missing. Parenthesis. Yeah. So if you want to filter with Stream API, you will simply write, this is the lambda expression we are writing. Okay, here it is asking to close with this bracket and also one more bracket. So each val, okay, you put the if condition like this. Again, you have to put else condition also. Whenever you are returning true or false, okay, so you have to put either true or false, right? So in this case, if you return only true, what happens in the false case? So that is the reason it is showing this error. You can write else return false. Okay, else return false. Numbers you can filter using filter function. After filter function, you want to print those numbers, each number. Okay, so you have collect, and also there are two, collect, collector, or you can use supplier also. So supplier, by consumer, like that there are so many things. So what I do is I want to collect as, we have one collector class, collectors dot, we have to list. So here I'm filtering the values and also after filtering I'm converting this into list. When you use collect means it will collect the values inside that. If you want to convert to list or set or map, you have to use the collectors class. In there we have to list. This you can store into again some object, list object. If you print this, even numbers will be printed, same numbers. So here one advantage is, instead of writing this entire thing, you can simply write the same thing. This is 3. This is 3. No need to write this entire expression. Remove everything. This remove everything. Just put this semicolon. No need to use equals equal to 0 also. Each val percentile 2. Okay. Let me put it as equals to 0. Filter percentile 2. Okay, this is fine. We are getting the values from integer array only, numbers list only. Stream filter, this is fine. One second. Basically, no need to use this also. 1 second, let me do one thing. Remove it. Each val percentile 2. No need to put the if condition also. No, it is not taking. So let me remove this collect. Wait. Yeah. Okay, so now dot collect collectors dot to list. This you can store into some list object, list 3. So no need to use the entire expression. You can simply use like this. Okay. If it is equal to 0, it will return true. Otherwise, it will take it by default. It takes as a false. If you print list 3, it will also print the same. Or if you put 1, it prints odd numbers. See, odd numbers here in the last. See, whenever you get any question to remove, to filter the values, even or odd values, if you write the logic like this, okay, you will get good marks in the interview. If you write this formal approach for loop, this for loop is again better. If you again use int I equals to 0, again I less than, or this size, list size, again if you take like that, that is the worst coding. Worst coding means that is a very basic level of coding. Okay, once you learn everything, you have to write your coding in this format. And also, if somebody written the code in this format, you have to understand it. Okay, so we have similarly like filter, we have map. See, map, it is accepting function. See, it is accepting function. Okay, so function, if you go to function, functional interface, built-in functional interfaces, it is a function. There you have one method, it is accepting any type of value. Okay, it can return any type of value. It can return any type of value. So go to our stream. Here it is accepting value. Okay, it can return any type of value. Return any value. Or simply you can write return, also no need to use misplaced constructor. If you want to collect, dot collect. Collectors dot, again to list or to map, whatever you want you can do. So list, this is mapped list. This is odd numbers list. Okay, let me print mapped list. What it is printing. See, if you observe here, when you filter, it is you are getting only filtered values. Okay, when you are filtering only filtered values. When you use map, to your list, for each and every value, it is adding the new value +5. This is a new list, new mapped list we can use. Similarly, we have one more thing, reduce. Stream dot reduce. Okay, so here reduce identity binary operator. What is this binary operator? Okay, so if you want to reduce if you want to map the list, you can use map. If you want to filter the list, you can filter. If you want to reduce the list, we have one more notation. So you have identity. You can use by function. So like function, we have by function also. Okay, so this is binary operator. What is this binary operator? Let's see. So here in built-in functions, so we have one binary operator. What is that? Let's see. Binary operator. Okay, let's put it as integer. New binary operator. So it has some method, implement unimplemented method. Okay, it throws some exception. Okay, unimplement method you have added already. Okay, why it is? Okay, here also let me put it as integer. the type new binary operator must implement the inherited abstract method by function. Oh, so if you want to again do this, so you have to implement by function also. Okay, so this I will explain later, you will confuse again. Okay, so again, if you want to reduce the map, okay, if you want to reduce all values, if you want to make it as all values sum, what you will do? If you want to do the sum of all these numbers, what you will do? So again, you will construct one for loop. Okay, construct one for loop. So you will take one by one value. Then what you will do? Again, one temporary variable you will take, and from the temporary variable, one by one value you will add. Right. So instead of that, we can do one more thing. So we can reduce the values. If you want to print the sum of values, how you can do? It's very simple. So you have list of values. Where is our list? Not this one. Okay, so just give me a minute. So in stream example, okay, in stream example, so reduce. So here you can pass two parameters here. Okay, one is binary operator. One is binary operator, and we have one more thing, integer, identity, and binary operator. So here I will take it as a 0, and I will pass two values. Okay, so one is val1, val2. So now you can do val1 plus val2. Okay, if you want to store it into some, okay, val plus val2, after done this, why it is, okay, this is val1, right? Yeah. Val2. If you want to store it into sum of values, if you want to print that sum, okay, the values, the total values in the list will be printed. So after mapping, you created a separate list. Okay, that is separate. So if you want to sum of all these numbers, you can use the reduce method. See, 155 is the value of these all numbers. And also this 0 also not required basically. It is directly, it is not accepting. No? Okay, so put that as 0. It's better. Okay, if somebody asks you to print the sum of all elements in a list, you have to use the reduce. If somebody asks you to map some values, right, you need to add, for each element you need to add +5. If they ask you to write a program, there is a list for each value, for each element you have to add a 5. Instead of writing normal for loop and taking the again values +5 again adding into the same index, that is not a good approach. So if you use map, it is very easy like this. Okay, the same map you can write, simply you can write, where is map? Written also not required basically, no need to use written also. Okay, so here simply just put, yeah, like this also you can write. A return statement no need to use, just while mapping. Okay, so like this we have to write our logics using stream API. Using stream API. Okay, any doubts or confusion in this map, reduce, filter?
No, Shiva.
Okay, it's very simple. This is filter. This is map. And this is reduce. You are reducing the list. You are mapping. You are adding some other values.
Shiva, reducing means decreasing the size na Shiva. But here reduce means sum of the digits.
Yeah, that's what. Suppose you have a list object. Okay, you want to make it as a single value, that entire list. Then that means reduce only, right?
Okay.
If you want to filter some values from the list, you can use filter. If you want to add some value to each element in the list, which means mapping, one-to-one mapping. Okay, many to one, one to many. Okay, you have one number. With that, you want to add one, you want to see. So let me show you like diagrammatically example. So you have some list. So you have some list. Okay, so you want to filter the values. So let me put some values here. Okay, so let me write some numbers. 11, 12, 13, 14, and 15. You have some numbers. So if I ask you to print only even numbers, you are filtering here. Filtering means from this list, you are filtering the one more list, that is 12 and 14. And 14 you are filtering. This is filter. Filter. Coming to map. I have one number, some number 5. You want to map this with some other list. You want to map this value with some other list. Okay, other list like, so let me write in this way, you will understand. This value you want to map there are some 5 values inside here. So you want to map this 5 with each and every element into some other list. How you will map? So like this we map, right, for each and element. Okay, in this case what happens, it becomes a single list. It becomes a single list. So this is called mapping. One value so now it becomes 16. This is 17. This is 17. It becomes 18 and 19 and 20. So this is called you are mapping with some value, right? We mapped with 5. This is map. Reduce. You have a list of values. You want to reduce it. So you have a map. Sorry, you have a list. You want to reduce it. So reducing means the entire thing you want to reduce. Okay, it becomes this value, this value, again this value, and this value, and this value. You want to make it as a single value, some single value. Okay, so this we are giving it as a sum. This is 29, 42, 54, and 65. This is reduce. Okay. Filtering some values, mapping with some number, combining everything into a single number, reducing. If you want to do, we have stream. Not only filter map stream, we have other usages with the stream API. By practice only, you will get that. Okay. Understand the concept where we use functional interfaces. So using functional interfaces and stream and lambda expressions, you can minimize your code length. Instead of writing some 1,000 lines of code, you can write in, like you can minimize the length of the code. And also very useful, easy to use. Okay. So yeah, so like this we can use the functional interfaces. So tomorrow we will discuss IO package. Okay, so let me stop recording.